All right, guys. Hi there. Welcome to what I guess is the first of an online lecture that I'm going to be doing. Um, I found it really difficult to write about how to do the following things that I need to kind of teach you, and so I really wanted to just make a video showing you how to do the things that I kind of want you to be able to do. I'm going to be using this online whiteboard program. The idea here is that you kind of do this along with me. I'll then set some problems, and then hopefully we can kind of understand what's going on with the ionic bonding topic, because it's really challenging. And I hope that you guys take this challenge as an opportunity to really better yourself and watch this video. You can go back over it multiple times, really think about how you are doing this task so you can kind of understand what's going on. To be able to do the task, though, you need to make sure that you understand how to draw atoms. If you don't know how to draw atoms, you need to make sure that you can do this. Please go look over my worksheet called C3 in the chemistry tab, and it will show you how to look at atoms and how to understand how atoms work. You also may need a copy of the periodic table of the elements. If you don't have one, they're very easy to get hold of. I'll tell you what, I'll upload one onto the assignment so you can see for yourself. Okay, so let's go for, I think the first thing that we need to do is look at how to actually make ions, what actually is an ionic compound. So first of all, what we need to do is work out what an ion actually is. An ion is an atom that has lost or gained electrons. And so because they've lost or gained electrons, they've become positively charged or negatively charged. If you lose electrons, then that becomes positively charged, positively charged. And so we call that a cation. You will have to remember these words, by the way. And if it gains electrons, then that's going to become negatively charged. And we call these anions. And again, you'll need to remember those names. We kind of use negative ion and anion interchangeably, and the same with cation and positive ion. Okay, so now that we know what these are, let's look at how they're made. Let's have a look at how we're going to draw positive ions. Positive ions lose electrons, and so what you need to do is first of all know what the structure of the atom that you're looking at is before we can look at the ion. All metals make positive ions. So if you're drawing a positive ion, it has to be a metal, and you can find those on the left-hand side of the periodic table, on the left-hand side of that stepped line. Let's pick a really easy one to start off with, one that's really common. Sodium, which has the chemical symbol Na, is one of the most common ions that we'll come across. This sodium, let's draw out the atom and see what's going on. So as you know, when you draw an atom, we're going to draw the symbol. You're going to draw our first shell, which has 2 electrons in. Now sodium is element number 11, which means that it has 11 electrons in. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Right now I've got 10 electrons. And so we're going to draw another shell here. I'm going to put our last electron in there. So this is a sodium atom. It is not a sodium ion. Now, when this actually loses its electron, it will lose the one on the outermost ring here. So this electron will fly away. And when it loses one electron, then we can just get rid of this entire circle here. We don't need this shell in at all. So when I redraw this, we're going to have our sodium, our first shell that contains 2 electrons, and our second shell that contains 8 electrons. Now this makes the sodium atom very, very stable, but it's not an atom anymore. It's become positively charged, and so we call this a sodium ion. If you're drawing this, you need to make sure the square brackets and the plus are on there as well. Now, let's have a look at something a little bit more complicated. Let's look at calcium. Now, calcium is element number 20. So we've got to get 20 electrons in here. So for the first shell, we're obviously going to have 2. For the second shell, 8 will fit in there. Then we can fit another 8 in the next shell. Ooh. There we go. And then we're going to have 2 electrons on the outside. So get all of my 20 electrons in there. This is the worst shell that I've ever drawn. But here you can see that we've got 2 electrons in the outside shell. So to get a full shell, it needs to lose those 2 electrons so that it will be nice and stable. So instead of losing 1 electron, this is going to lose 2 electrons. Now I'll get rid of this electron, I'll get rid of that electron. So when I redraw this, we're going to have calcium 1, only 3 shells in it this time. And we're going to have 2 in the first shell. 1, 2, 3, 4, 5, 6, 7, 8 in the second shell. And 1, 2, 3, 4, 5, 6, 7, 8 in the third shell. Again, you draw this like this. You do square brackets around it. But if you notice, we've lost 2 electrons. So this has to have a double positive charge. And we write that as a 2 plus to say that there's 2 lots of positive charge. It's twice as positive as the sodium ion. Right, let's have a look at negative ions now. Negative ions are things like oxygen or chlorine. Now, let's do chlorine because chlorines are quite easy to do. It's a very common one as well. I'm going to use dots for these negative ions, but you can use dots or crosses. It doesn't really matter. Chlorine is element number 17. So let's draw these 17 electrons on this diagram. Oh, let's just go back there. So you want to draw 17 electrons on this diagram. I think it's going to be a lot easier for me to draw the circles first. Here we go. Ooh. There we go. Now, if you notice this one, it's going to be actually really difficult for it to lose 7 electrons. And because it's difficult for it to lose 7 electrons, it's actually easier for it to gain 1 electron. So instead, what will happen here is that an extra electron will come into the atom and it will go here. So when we gain 1 electron, instead, what we end up with is 3 shells, but now the shells are going to be completely full. So we're going to go from having 2, 8, and 7 to 2, 8, and 8. But here's the thing. You have to show that the extra electron you've gained has come from somewhere else. So instead of drawing the next electron as a dot, you draw it as a cross instead. Right. We're going to put the brackets around it. And the charge of this one is going to be 1 minus because we have only added 1 electron to this. Finally, let's have a look at a group 6 element, oxygen. So here's my oxygen atom. This is obviously going to have 2 electrons in the first shell, and then we're going to have 6 electrons in the second shell. So here we go. Obviously, this has 2 places. It's got 2 gaps. Look, you've got a gap here and a gap here to make it full. So this guy needs to gain 2 electrons instead. So when I draw this out, I'm going to draw my oxygen symbol, my first shell, which has 2 electrons in, and my second shell, which now has 8 electrons. And just like before, one of these needs to be, you need to do the dots first, and then because we're gaining 2 electrons, you need to have 2 of them drawn as crosses. We're going to have our square brackets, and this time this is a 2 minus charge because it's gained 2 electrons. Okay, thank you very much, guys.